Welcome to Introduction to Video Security System, VSS Fundamentals, brought to you by Pelco. This course is a guide to the basics of any video security system. This section is an introduction to camera lens design. The purpose of any lens is to properly focus an image on the faceplate of the camera's sensor. At the end of this course, the learner will be familiar with the basics of camera lens design. At the end of this section, you will be asked to complete a few assessment questions. The purpose of any lens is to properly focus an image on the faceplate of the camera's sensor. The area that the camera sensor will focus on is determined by the focal length of the lens. The lens opening or iris of the lens assembly determines the amount of light allowed to reach the camera's sensor. The type of mounting, C or CS, determines the focusing distance between the lens and the camera's sensor. Depth of field is the area within which an object located in the field of view remains in focus. As the lens aperture closes, higher f-stops, the greater the focus depth becomes. Fixed focus lenses are the simplest type of lenses, and therefore the least expensive. They will provide good coverage of a scene, but objects will look smaller on the monitor. The angle or the area that the lens will view remains constant. This is not a good lens to use if identification is an important factor. The focal length of the lens is measured in millimeters. Focal lengths range from 2.1 millimeters to 75 millimeters. There are three types of fixed lenses: wide-angle lens, standard-angle lens, and telephoto lens. A varifocal lens combines a normal and wide viewing angle into a single lens assembly. This type of lens allows the installer more flexibility when setting the view angle for a customer. This lens is used in applications where a customer needs to make changes. The normal viewing angle for varifocal length lenses is usually about 30 degrees, with the wide angle being between 60 and 80 degrees. 65% of all applications select lenses in this normal to wide range. A varifocal length lens is a lens which has a variable focal length that can be set manually, and any adjustment in the focal length will require the lens to be refocused. A zoom lens is designed so that manual movement of an external ring on the lens can adjust its focal length, or by a remote-controlled motor assemblies. Unlike the varifocal length lenses, zoom lenses offer much greater focal length range. Zoom lenses are normally associated with systems that incorporate a pan and/or tilt unit, offering wider flexibility to the VSS operator. The focal length can be adjusted within a range, for example, 6 to 48 millimeters, without affecting the focus. There are two types of zoom lenses: manual zoomed lens, motorized zoomed lens. A pinhole lens is a lens that has a very small front opening diameter. This opening usually is 0.06 to 0.25 inches in diameter and is used for covert security. The lens variations include straight and right angle, manual or auto iris, narrow taper, or stubby front design. Due to the special lens optics required, the minimum f-stop rating of these types of lenses is relatively high, 2.8 to 3.5, and extra light may be required in order for the camera and lens assembly to produce a quality picture. An aspherical lens is a lens designed with a non-spherical shape. It refracts the light passing through it to lower the lens aperture. This increases the light passing through it. With a wide-angle lens, it decreases barrel distortion. Aspherical lenses should be considered when a wide-angle, low-distortion, high-speed lens is required. This lens, in combination with low-light sensitive cameras, may sometimes eliminate the need for additional lighting or intensified type of cameras. Color cameras require additional lens parameters. The term used to identify these parameters is known as color-corrected optics. Without color-corrected optics, the lens will still pass all colors of the light spectrum, However, each of the colors will not focus at the same point on the image plane, causing an out-of-focus condition. Proper lens selection for a color system can be just as important as selecting the proper light source. There are 4 or 5 different methods for calculating a lens. The formula used to determine the lens size for any given application requires the following information: distance between the camera location and the scene, subject dimensions or how much of the scene you want to view, format of the camera you are using. A camera format defines the size, light-sensitive area of the imaging device used in the camera. It is provided for information to enable the installer to match the camera to the correct lens. The format of the lens is not a requirement in determining the viewing angle. As a result, changing the format lens used does not cause any change in the viewing angle. The only requirement is that the lens format be equal to or greater than that of the camera used. This prevents shading of the video picture, more commonly known as the porthole effect. Apparent change in the focal length of the lens occurs only when the camera format changes. Example of a lens calculation formula.